Hello, I'm McCarthy. I'm a scientist at Waters Corporation, and I'd like to discuss a poster titled Chiral and Achiral Reaction Monitoring with sub-2 micron particle columns with CO2 chromatography. First, as an introduction, generally for a medicinal chemist, once the chemist decides what type of molecule they're going to make, they go through and start doing a synthesis of a particular molecule. And then once a chemical hit is identified, they go through a process of optimizing that synthetic process. During each of those processes, there is a requirement to monitor the reactions, to look at their progress, to determine whether or not product is being formed, if starting materials are being consumed, or if any impurities are being formed. In terms of monitoring these reactions, the sample throughput has to be very rapid in order to get real-time or near real-time results out of the experiment. In addition, in the laboratories, oftentimes many instrument would be shared with many chemists. Therefore, high throughput is even more beneficial to ensure everyone gets their results in a short time period. In this presentation, we're going to discuss the use of ultra-performance convergence chromatography and how that technology can help a chemist make decisions in real time. To begin with, I'm going to discuss chiral and achiral screening. This is often used during the synthesis of a chemical entity to ensure, number one, that the product is being formed and to confirm the yield, and in addition, that the correct chiral and enantiomer is being prepared. You can see here, using the ultra-performance convergence chromatography, or UPC squared system, that we are able to monitor both chiral and achiral analyses on the same chromatographic system with the same chromatographic eluents, with all of the columns necessary being on the same system. In this particular case, it was very useful to have all of these columns on the system at the same time because we were able to do, as I mentioned, the achiral analysis, but two different chiral columns were needed to do the analysis of the starting material to monitor its chiral nature and the product on a different chiral column. So two columns are needed for each of the chiral product or the chiral starting material. Moving on, discussing the use of convergence chromatography for reaction monitoring and subsequent optimization. This is an experiment we had performed essentially working as though we were in a medicinal chemistry lab where we had to prepare an intermediate during the synthesis of clopidogrel. The literature reaction called for the use of tetrahydrofuran, or THF, as shown in the left-hand figure. Following the literature procedure, we found that the reaction progressed very slowly up to around 265 minutes, at which point we let the reaction go at reflux overnight. The following morning, we did an analysis of that reaction mixture and found still there was roughly 50% yield of the desired product. And you can see in the graph below a graphical depiction showing the reaction progress, indicating that the reaction rate was fairly slow. To overcome the slow nature of the reaction, we substituted dioxane for THF, given the fact that it has similar chemical properties and should yield a higher reaction rate. Again, using the UPC squared system, we were able to monitor the reaction over the course of a variety of time points. And shown in the graph below shows the rate of reaction using the dioxane, indicating that the rate of reaction had increased, and in addition, the overall yield of the reaction had increased. And the speed with which we could do the analysis, coupled with the robustness of the UPC squared platform, allowed us to accurately track the reaction progress and optimize the synthesis so that we would have the minimal amount of reaction time. Finally, a last example of reaction monitoring, which is during the synthesis of imatinib. In this particular example, this is a reduction of a nitro group to the corresponding amine. During the analysis of this reaction, we found evidence for two different intermediates, both of which were being converted into the final product. You can see very clearly that we can confirm each of those species using mass spectrometry coupled with the UPC squared, and we're able to track the reaction progress. What was interesting about this reaction is that as we let the reaction progress, we found not only evidence for the final product, but we also found evidence for two over-reduced species, which had a higher molecular weight than what we were expecting. With this information, we were able to determined that the reaction either needed to be stopped earlier or that we would need to do purification following the synthesis of the material. So in conclusion, with the three examples that I've shown, the chiral and achiral screening, the reaction optimization, and just doing the reaction monitoring, we've shown that UPC squared is a suitable technology for use in a medicinal chemistry lab. In addition, it offers additional benefits by being able to do analyses that would generally take multiple instruments to do the analysis and do them on a common platform. So with that, thank you for your time, and if you have any more questions, please visit waters.com.